So we started with the definition of Laplace transform, which involves integration of a two-dimensional variable with respect to time. We tried our level best to inform about how the integration takes place. The difference now is it's a two-dimensional integration wherein we have got f of s is equal to minus infinity to infinity so ft is a function which at any given point of time t be a point in 2D plane. Same is the case t raised to minus st. So gt, which is equal to ft raised to minus st, becomes again a variable which can take any value in the plane, and that we are integrating now. We are integrating gt dt, and the limits are minus infinity to infinity. So that I can say as limits right now, I can say as t1 and t2. So we have noted down that for a single dimensional variable gt, this integration particularly is the area under the curve, or t2 minus t1 into average of dt over the entire range of t1 to t2. So we talk about average of gt. Talking about average of gt can be very easily thought of, because gt was taking some value at every given point, and then its continuous average, which I can say to be a discrete average by taking a large number of points. So, and this one can very easily understand that this is, if this is t1 and if this is t2, then average would be somewhat like this. Is it alright? If you play mischief, I will take you to such a task that you will never forget what happened to you. I want absolute silence, and if some mischief takes place, then I will punish the entire class till the culprit is known, and that punishment go to any extent. But now the problem becomes when gt becomes a two-dimensional function. That time, when we talk of average, now gt can take any value in this plane. So we can plot the locus of gt, where t is not shown here. This is the locus, t is the x horizontal axis, and gt is the vertical axis. Here gt is both axes, and I am plotting the locus maybe like this. So from at t equal to t1 it was gt1, it is now gt2, and it travels through this path. So in that case, what do I do? In that case, I have to take average, two-dimensional average. Then I can think two-dimensional average. That is also possible that you can have very easily by two-dimensional addition, or you can separately take the concept of integrating a two-dimensional variable can be independently thought to be integration of two one-dimensional variables and then their combination by like Argand's diagram. Integration of two one-dimensional variables and then taking it correct means consideration of two one-dimensional integrations together, we can think of. This doesn't become, now a question will be, does it become volume? It doesn't become volume in that sense. It doesn't become volume in that sense. It's actually strips are there and small area of small strips, and with auto cancellation with the diagonally opposite area. The area is auto cancelled by diagonally opposite area. The area means, suppose if now it moves like this, suppose if for some time it is constant, for some time it is constant, then for some time it falls like this. So this strip is there, it is constant, strip is like this. So at some point, if it is a reverse in this way, then area would be on this side. So diagonal areas cancel out each other. It doesn't become volume as such, and like that we get the final answer. Or we can think of average of all the points which may continue for any period. Average of all. So I want that everybody of you must be in a position to understand the concept of average of multiple points in a 2D plane, and that average multiplied by T1 minus T2 minus T1 is the two-dimensional integration. Otherwise, we can separate this out. We can separate this out to be x component and y component. Gt is a two-dimensional function, means at any point of time it occupies a position. This I can separate down as gxt and gyt. I am deliberately using the word gxt and gyt rather than real and imaginary parts, right? So gt is a function which can occupy a point in 2D plane, can be said to be collectively thought or collectively comprised of two independent functions, gxt and gyt, where gxt is a function which occupies a real value at every given point of time. Gyt is also a function which occupies another real value at given point of time. To be more precise, both real part and imaginary part are real, right? Gxt and gyt are real functions. Then we can think of integration of gxt in this manner, integration of gyt in this manner. This is average of gxt into t2 minus t1 plus average of gyt into t2 minus t1. So that will become one area for gxt, one area for gyt, and that taken together will again a two-dimensional point. Its integration is integration of gxt dt. This will be looked upon as integration of gxt dt, integration of gyt dt, both from t1 to t2, and what this will be, integration of gxt dt from t1 to t2 will be a real number. That has to be a real number. Maybe finite, maybe infinite, it is not mattering now. This would be another real number. And both of these real numbers collectively represent one point in the 2D plane, right? So this I can consider maybe as since I am using. And now again, if these are taken to if t1 is minus infinity and t2 is plus infinity, in that case t2 minus t1 becomes infinite into average. So if this is something which is, now it is very clear that the base width is infinite. Integration represents area, that is base width into average height. If average height is infinitesimal, then this integration will be finite. If average height is finite, integration would be infinite. So then this I can consider to be fx of s, and this I can consider to be fy of s. So fx of s and fy of s collectively represent, so this now, what is gt? Ft into e raised to minus st dt. So ultimately this is t as a variable and s as a parameter. When I integrate, t vanishes, so it remains function of s, and s I can now vary from, not from minus infinity to infinity, s can vary anywhere in the plane because s itself is a two-dimensional point, two-dimensional variable or parameter. So this becomes fx of s and fy of s, and fx of s and fy of s together represent fs. So what we can say that with this all exercise I can get a mapping. The mapping cannot be plotted because it goes to a 4-dimensional entity. The mapping is like this. S can be anywhere in the plane and f of s is in this plane. So this s can be thought to be sigma plus j omega. So this is sigma and this is omega. Will provide me sigma 1 omega 1 will give me a point s1 in s plane, and here for that I will get fx at s1 and maybe fy at s1. That would be another point. So there will be mapping, one-to-one mapping of s1. As long as this Laplace transform exists, it is finite, they will be mapping from one-to-one mapping. S1 would be taken as f of s1. So Laplace transform is an integration of ft e raised to minus st dt for entire time. Wherein the things which are required to be understood are, first, the concept of integration of a one-dimensional function ft dt. What we need to understand, if definite integral of in general fx dx from x1 to x2, that I think very well known now. Fx dx from x1 to x2 is average of fx over x1 to x2 into x2 minus x1. That needs to be understood. Then that can be extended to a two-dimensional function, either by considering average in the 2D plane or considering it is to be a combination of two one-dimensional functions. Then how we are comprising this, that is, it is now gt dt is a two-dimensional integral. Gt is a two-dimensional function which can be thought to be gxt and gyt from minus infinity to infinity. Then how gt is comprised of? Gt is comprised of ft into e raised to minus st. E raised to minus st is a two-dimensional function which may take 4 different forms depending upon what is s, and ft is the originally given function. So we will be in a position to find for various ft's how they will get means those ft's which are well defined would be getting transformed into this. Means what Laplace transform tells, Laplace transform maps the relationship of integration of the given term as a function of s. The integration of ft e raised to minus st dt becomes a defined and definite function of s for some restrictions. It may exist, it may not exist. But if it exists and if it is finite, in that case we get this unique mapping. So by this, what is the conclusion? What is the conclusion? So right now I think the time is not opportune to come to a conclusion. At this point of time, let us try to get ourselves acquainted with various terms. So I think that what is Laplace transform is sufficiently understood by you. Now we can take few examples of Laplace transform. What will happen for impulse as a function? If ft is impulse, what will happen? If ft is impulse, what happens is ft is infinite at t equal to 0 and 0 elsewhere, and at t equal to 0 e raised to minus st is 1 irrespective of s. At t equal to 0 e raised to minus st is 1. irrespective of s. So the Laplace transform reduces to a simple expression, that is just 0 minus to 0 plus. It is actually, we can have delta t, we can write delta t, we just may write delta t into dt. And now what it will be? Delta t dt, it represents the area, and that area has to be 1. Why? Because delta t is having infinite height and 0 width. Delta t is having infinite height and 0 width. So delta t dt actually is an impulse. Is infinite height and 0 width. So this is represents a unit area represented by a 0 width pulse. So that would be 1. So Fs is independent of S. For impulse input, for Ft to be impulse, Fs is independent of S. Likewise, you can compute for weight. Means I would like that everybody of you should think something and try to come up with a conclusion on these issues. We would be having a rigorous oral examination on 5th and 6th of April. So that time I will individually test everybody, because these understanding cannot be understood by what we can some kind of test as such. So I think I had given you theme of Laplace transform on which you can work for some time. But the problem in Laplace transform right now, what one may feel, is that because of the complex or two-dimensional nature of variable s, we cannot get complete field of Laplace immediately. So we try to go a step further and try to focus more on that. And that further step is taken by putting some restrictions on s. The restrictions on s are: the real part of s is 0. The real part of s is 0. So when real part of s is 0, s is sigma plus j omega. So when real sigma is 0, then what becomes is, and it is now quite interesting in nature, and this is called as f of omega. And now we shall, from now onwards, we can focus much attention on this, and then we shall go to Fourier series. I have just changed the sequence because this is very crucial in nature. So you look at the expression, f of omega is equal to ft e raised to minus j omega t dt. F of omega, it is just a single expression over which many generations of electronics engineering students have spent the many crucial hours. For the reasons known only to him, Fourier has thought of this kind of some transformation, where ft, now what has happened? T is a real variable, omega is a real variable. T is a real variable, omega is also a real variable. Ft, which is a function of t, can be a two-dimensional function of t, and f omega, which is a function of omega, can also be a two-dimensional function of omega. When I say two-dimensional, it can be one-dimensional also. So usually ft is one-dimensional, usually, but we may allow two-dimensional also. Usually ft is one-dimensional, and then we get f of omega. So let us try to think to the fullest level of our thinking capabilities. What does it represent? So what it tries now, ft is being considered from its value at minus infinity till infinity together. So it becomes independent, this entirely expression becomes independent of t because all values of ft are considered. So one function means this is a transformation or a mapping from function of one variable into function of another variable. This is function of one variable, means when I say ft is equal to cos omega, means that the value of the function depends on t in a given manner. ft sin omega t, ft e raised to t, ft equal to 1, ft equal to delta t, or ft equal to random. There may be a deterministic function, there may be a non-deterministic function. There may be a function which would be time limited, there may be a function which would be time unlimited. Means for example, ft I can have a simple function ft equal to 1 for 0 less than capital 0 less than t less than capital T and 0 elsewhere. Or it can be minus t by 2 to plus t by 2, 0 elsewhere. Right? So if ft can be a ft equal to, I can have ft equal to e raised to j omega not t. I am therefore using omega not because I want it to be some constant where it is a variable. J omega not t. You may find in the book that variable used might be this, but I think this is more convenient. So what this is? This is a function which is two-dimensional in nature. Means at given point of time it will occupy a point in 2D plane. This is also two-dimensional, but it always travels on this path. It is not that it's only cos omega t. I can consider to be two-dimensional with the other part to be 0. It always travels in this range, cos omega t. Whereas this e raised to minus j omega t, that will be traveling in this manner. In this manner it will rotate. Is it clear? So the idea of functions is very clear to you. A two-dimensional function in general and a special case as one-dimensional function. Everything is quite clear to you. Is it okay? Now we shall study the impact of this. We shall study the impact of this by taking various simple cases, and we try to map the transforms and then try to extract what meaning we can get from the transforms. So I think the idea is very clear that I am multiplying now ft e raised to minus j omega t. So what I am trying that again e raised to minus j omega t is a phasor rotating at an angular speed of omega. In which direction? Clockwise direction. Is it clear? So ft means when I was having e raised to minus st, it was difficult because it was either expanding or contracting like this. But now it is very clear that for a positive omega, it rotates in this way. As omega increases, speed of rotation increases. For negative omega, it rotates in this way. For 0 omega, it is always here. Omega equal to 0 is always here. For positive omega, it rotates like this. For negative omega, it rotates like this. So for given omega, you can compute the integration. How? Let us say, I will give you a very simple example. We can take different examples of ft and try to find the answers by trying to visualize them, otherwise by formula. So now we have got a simple one. ft is equal to 1 for the duration minus 1 to plus 1 and equal to 0 elsewhere. It's a very simple thing which we have considered. ft equal to 1 for the t minus 1 to 1 and 0 elsewhere. Then let us, I would like to give you as a classwork that everybody compute it independently, and then we can think of how to proceed further. Finished? Present, sir. Everybody is finished? So since ft is 1, its straightaway becomes, this integration becomes simpler. From minus 1 to 1, e raised to minus j omega t. Is it okay? Now we shall think it. You can find it by integration formulae. We shall also try to have its mathematical interpretation. It becomes a simple phasor rotating with a speed of omega in clockwise direction for positive omega, let us say. So what is going to happen? For a given omega at t equal to minus 1, what will happen? For a given omega, what we can take any value. If some, let us say omega naught, or if that is not agreeable to you, you can take some value as pi by 8, right? Omega equal to pi by 16, let us say. omega equal to pi by 16, right? Omega equal to pi by 16. So at for omega equal to mean what will happen? It would be giving me different values for different omegas. So I will calculate for one omega. So at pi, for omega equal to pi by 16, what will happen? At t equal to minus 1. At t equal to minus 1, where would be the e raised to minus omega t? For omega equal to pi by 16, it is pi by 4, pi by 8. So it will be somewhere here. Is it clear? Are you getting me? So for omega equal to pi by 16, the phasor would be here at t equal to minus 1. Then as t proceeds, what will happen? As t proceeds, it will start rotating like this. Okay? Sorry, at t equal to minus 1 it will be here. Sorry. At t equal to minus 1, it would be here, right? So then what will happen? It will start its rotation in clockwise manner, and at t equal to 0, where it will come? At t equal to 0, it will come here, right? And at t equal to plus 1, it will come. Is it right? It will come here. So what is going to happen? So what is the answer? So what is going to happen now?
Stress the sector.
Then it would be not area of sector.
Arc.
It will be now average of this into 2. Why? Because this is 2. Average, let everybody understand the concept of average of all these points. Let everybody understand the concept of average of all these points. We will draw it in an exaggerated scale. Considers all the points. So what would be average of all these points?
0.
Why no? It will not be 0. It will not. This is not the average of all the points. Where the average of all the points will lie?
On the real axis.
On the real axis, and where it will lie? Somewhere in this region. Are you getting me? It will lie somewhere in this region. This you can independently think in another manner. This is now GT, because this is 1, and limits are simple, so it is gt. So this I can say to be gxt and gyt. What is gxt? This I can consider to be minus 1 to 1. gxt is cos omega t dt, because cos of minus omega t is cos omega t only. And what is gyt? Minus 1 to 1 minus on the other side minus sin omega t dt. Now you can look towards both of these independently and then compute these two and you can come to the answer. So when we look at cos omega t dt from minus 1 to 1 and sin omega t dt from minus 1 to 1. So now it is t. Now why I can plot? Because both are one dimensional. So cos omega t dt. So for given omega, say for given omega equal to pi by 16. For omega equal to pi by 16, what will happen? For omega equal to pi by 16, what is going to happen? For omega equal to 0, what is going to happen? For omega, I am trying my level best and trying to be as simple as I can. For omega equal to 0, what will happen?
Phasor will be static.
For now, why you are looking at phasor now? We have since phasor is difficult to understand, we have broken away the phasor. Cos omega t one separate term, sin omega t another separate term. So we are not talking of gxt dt. What is gxt? gxt is cos omega t. So for omega equal to 0, what will happen?
1.
So it would be straight away 1. Is it alright now? For omega equal to 0, it would be straight away 1. Is it clear? No ambiguity? For omega equal to, when just now let me try to build some thinking within you. Omega becomes just above 0. Omega becomes just above 0. So what will happen now? When omega becomes, this is cos omega t on the vertical axis. When omega is 0, cos omega t is 1. When omega becomes just more than 0, how the curve will change? This one, how it will change? How? Means it will like this. Omega very small means very small frequency, much larger period. Is it right? Then at one point of time it will become, at what time it will become like this? This should be theta, it should become pi by 2. Omega t equal to theta, t equal to 1. So at omega equal to pi by 2, it would be like this. If it increases further, it would be like this at double. It's not exactly not to scale. So at omega equal to 0, what was the area? At omega equal to 0, why infinite? We only up to minus 1 to 1 we are talking about. So at omega equal to 1, area was 2. At omega equal to, sorry, at omega equal to 0, at omega equal to 0, area was 2. At omega equal to pi by 2, what is area? At omega equal to pi by 2, what is area? This one. What is this?
Just more than half.
It is 1 actually.
Half.
This is replaced with this 2. No? So this becomes 1. At omega equal to pi by 2, it becomes 1. At omega equal to pi, what happens?
Half.
Not half. At omega equal to pi, this part and this part cancel. This part and this part cancel. Below we can say negative. So this becomes 0. Then at omega equal to 3 pi by 2, what will happen? What will happen? How 1? At 3 pi by 2, it will be like this. This would be like this. You minus something but not 1. You minus something but not 1. So what this would be?
One third. Minus one third.
Then when it increases further, what will happen? When it increases further, it will increases, it will shrink, again it will come to 0. Here, so first it is complete flat. Then 1/2 cycle. Then when 1/2 cycle is there, some positive area. From flat, for omega equal to 0, it is flat. That is, area is 2. From that, it comes to 1 for 1/2 cycle. Then from that, it comes to 0 for 2/2 cycles. Because when 2/2 cycles, 1 full and 2 half on negative side. Then when it increases further, it becomes 3/2 cycles. 1 positive, 2 negative. So it becomes something negative, maximum negative. After that, 4/2 cycles. 4/2 cycles. So there are 4, it is 0. Then when 5, it is positive. 6, it is 0. 7, it is negative. 8, 0. 9, positive. But each time, area reduces. So, you may think of plotting a function for omega. At omega equal to 0 is 2. Right? At omega equal to 0 is 2. Then from 2 it comes to 0 for omega equal to pi. Pi, 2 pi, then 3 pi. These peaks will be rotatless. Is it clear now? So, the integration of ft cos omega means ft raised to minus j omega t is thought to be ft cos omega t, where ft is 1. So integration of cos omega t dt for minus 1 to 1, integration of cos omega t dt for minus 1 to 1 would be this, and for negative side it would be a replica. Same. Just and what about the second term now? Second term, sin omega t for omega equal to 0, it is 0. And you will find that for sin, always whatever is, since it is symmetric from minus 1 to 1 and sin is antisymmetric. So, whatever we get here, exact reverse would be on the other side. So, this will always be 0. So, always be 0. So, the gyt dt is always 0. Gxt dt is like this, therefore total integration is this. And this you can easily solve by your formula also. It comes out to be 2 sin omega upon omega, correct? 2 sin omega upon omega. At omega equal to 0, we know that limit of sin omega upon omega as omega tends to 0 is 1. So at omega equal to 0, sin omega upon omega is 1. So the function is 2. Function is 2. Right? Is it clear? ठीक